Greetings to all. In today's session, we are going to discuss about the chemistry which is helpful for the entrance examinations at international platform and also in the national level India, that is regarding JEE Advanced, JEE Mains Chemistry examinations and also NEET Chemistry for medical entrance exam. Telangana NEET examination and Andhra Pradesh NEET exam as well. Apart from this, any aspirants which are preparing for the competitive exams towards any government exams. So for all these, this content will be very much helpful because all these are retired from the previous year question papers and properly answered, and the explanation is provided will help for to crack whatever you are aspiring for. Let's enter into our question number 1. Copper and hydrogen can each be formed by electrolysis. These are the components produced by electrolysis, right? At which electrodes are these elements formed? So here the process is said to be electrolysis. Electrolysis is nothing but the cells are two types. One is called a galvanic cell, second is called electrolytic cell, right? So let's move on to this galvanic cell over here. Galvanic cell means where chemical energy is converted into electrical energy. Electrolytic cell means reverse of that reaction where electrical energy gives rise to the chemical reaction. So that in the galvanic cell, if you observe, hydrogen is taken as anode and copper is taken as cathode. This is in accordance with this galvanic series. If you observe this, hydrogen is laying just above the copper in the serial order, so that hydrogen having more ease to release the electrons and copper having tendency to accept the electrons, so that this is the way we can construct the galvanic cell. But within the problem they mentioned about electrolysis, so that we have to reverse the entire process, hydrogen taken as the cathode and copper taken as the anode, so that the correct answer for the question will be B, where copper will be regarded as the anode, hydrogen will be taken as the cathode in terms of electrolysis. Okay, so option number B will be the correct answer. Copper will become anode and hydrogen will become cathodic reaction. Reverse of the galvanic cell should be considered. And let's move on to question number 2, where the diagram shows the 4 chemical reactions. 4 different chemical reactions are provided, and we have to observe, we have to identify which is called the endothermic reaction. Okay, so first of all we have to know what is meant by endothermic, then only we will go with which will comes under endothermic. Endothermic is the reaction where heat absorbed to perform the reaction. If heat absorbed in order to carry the reaction is called endothermic. While doing the reaction, if heat is evolved coming out, that is called exothermic reaction. In this first option, if you see, calcium oxide is added with water. Drops of water added to calcium oxide. So steam is generated. Heat is coming out. When heat is coming out, heat exerted from the reaction, that is said to be exothermic. So it is not the part of answer. Move on to option number 2, where combustion of natural gas. Gas is taken and combusted so that flame is generated. That is evolving the heat outside, so that it is also the part of exothermic reaction. Natural gas combustion is also the part of exothermic reaction. If you see thermal decomposition of limestone, limestone is a calcium carbonate chalk. That calcium carbonate, if heated, if you are heating, what happens, that calcium carbonate got converted into calcium oxide and carbon dioxide. So that heat is absorbed in order to break that compound. This is a kind of endothermic reaction. Endothermic reaction only asking for, so that correct answer will be option number C. Heat is absorbed. If you see this, arrow is inclined towards the compound absorbing the heat, endothermic in nature. Move on to option number D, acid and treated with alkaline solution. Simply you can observe neutralization reaction over here. Upon neutralization, if you observe, initial temperature is at the bottom. After adding this base, its temperature got raised, so that final temperature of further reaction, so that heat is evolved, heat is increased. Again we can say it is the exothermic. So among all the reactions, decomposition of limestone is the simplest example, comes under endothermic reaction. Option number C is the correct answer. So here, if you observe, exothermic means heat is coming out, arrows are inclined outward, so that exothermic reaction. If you see the arrows inclined inward, that is called endothermic reaction. Both are prominent and very important in the chemical synthesis and the transformations as well. Thermal transformations are studied under the concept called thermodynamics. In that regard, exothermic and endothermic plays a vital role. Right. Move on to question number 3. Which of the following set of quantum numbers represent highest energy of the atom? Highest energy of the atom to be predicted from all quantum numbers. Principal quantum number n is given. Azimuthal quantum number or angular quantum number value n is given. Magnetic quantum number n is given. S means a spin quantum number. First of all, we have to identify which quantum number represent what concept, what information is given from the quantum numbers, right? N is the principal quantum number which is specific for the size of the orbital and energy of the orbital. L is the angular quantum number that related with the what dimensions of the orbitals. And M is the magnetic quantum number which represent number of subshells present in that. S is the spin quantum numbers rotation, direction of rotation of electron, positive spin or negative spin can be given. Principal quantum number, size and energy of the orbital. Secondary is the orbital shape, dimensions will be depicted. Magnetic will be how, in what way orientation of orbital will be laying. Spin quantum number, in what direction electron is spinning. Clockwise manner or anti-clockwise can be predicted. Size of the orbital, energy of the orbital purely laying by the principal quantum number. As the principal quantum number increases, energy of the orbital also increases. Highest principal quantum number is given only in the option number A. N is equal to 4 value, highest energy accompanied with this one. N is equal to 3, N is equal to 3, N is equal to 3. So that simply you can roll out. Option A is the correct answer, and remaining all are 3 principal quantum numbers somewhat less than this option number A. Right answer will be option number A. Let's move on to another question. Question number 4. This is also related with the JEE mains and advanced question paper. The orbital diagram in which both the Pauli's exclusion as well as Kunda principle got violated. Right? Both the formulas. Okay. Filling of orbitals are possible in accordance with the 3 main concepts. One is called Auger principle. Second is called Hund's rule. Third is called Pauli's exclusion principle. Any orbital filling requires consideration of these 3 fundamental rules. Then only we can reside the electrons in their respective orbitals. Okay. So if you are considering these many kind of filling of electrons, there are Pauli's and Hund's rule got violated. Let's see in which it is. In all the orbitals, they are given with S and P orbital sets are provided to you around the central element. We have to predict where you can find a violation of Pauli's and Hund's in the same option. Okay. In order to get that, first of all, we have to know what is Pauli's and what is Hund's rule. Pauli's exclusion principle is nothing but no 2 electrons of the element are having 4 quantum numbers same. Any two quantum numbers are contradictory. Any 2 quantum numbers get varied, even though remaining 3 quantum numbers are similar, but one quantum number, at least one quantum number will be changed, then only that is acceptable, right? That is called Pauli's. Hund's rule means after filling of one electron in the each degenerated orbital, then only pairing of electron is possible, right? So here, if you observe option number 1, so here these 2 electrons are having, in p orbital, these 2 electrons are having principal quantum number same, angular quantum number same, magnetic quantum number same, spin quantum number also same. So that all 4 quantum numbers are same for this p1 electrons. That's why Pauli's exclusion got violated. 4 quantum numbers must not be same, so that we can decant that. And Hund's. If you observe the Hund's rule, this s orbital obviously of considerably less energy, so that you can fill 2 electrons over here. If you see p orbitals px, py and pz, all three are degenerated in nature. In order to fill the three electrons, in accordance with the Hund's rule, one electron should be singly occupied first. Here, two electrons are there, one electron. This is 100% wrong. Here, Pauli's as well as Hund's both got violated only in the option number 1. This is only the correct answer. Let's get the detailed explanation for both. Hund's rule is given with 1s, 2s and 2p orbital filling with it singly occupied. Then only if extra electron is coming, then only you can add one more over here. So, but if you are filling that third electron into this one is 100% wrong. And this is changing its spin is also wrong. Always first electron must be given with upward arrow. That means a positive spin is accorded for that kind of electron. So that correct Hund's rule will be option number 1 only. Electrons fill the subshell singly before forming any pair of electrons. Singly occupied orbitals are of same spin. That is accompanied by this first kind of representation only. And Pauli's explanation is provided over here. If you see 2s orbital is having two electrons spin parallel, both are upward only. But both the spins are plus half only. Plus half spin for the same orbital is 100% complicated. This may not be acceptable. One is in clock, another in anti-clockwise manner should rotate. This will be the right representation. Then only all four quantum numbers will be satisfied over here. So that in the same regard, you can observe option number A, Pauli's exclusion got violated. Hund's rule is also violated. Option A is the right answer for question number 4. Let's move on to question number 5. It is the kind of a question given with the hydrolysis reaction. We are taking calcium carbide. This is the part of organic chemistry where synthesis of acetylenes. It is a part of synthesis of acetylene, triple bonded compounds. In that chapter we can observe as a part of organic chemistry, right? Calcium carbide. Calcium carbide, two carbons are bonded with a triple bond over here. And here it got hydrolyzed by means of deuterated water. D2O is the kind of deuterated water. Hydrogen isotope was taken for the hydrolysis process. And one of the product is generated that we have to identify. In either byproduct is given to you, that is calcium OD taken twice. This is called the deuterated hydroxide. Calcium deuterated hydroxide will be generated. Simply it is the kind of hydrolysis reaction where where general water is used, H2O is used. The product will be, one is acetylene, second is about calcium hydroxide. Acetylene and calcium hydroxide will be generated. If you see that reaction, you can clearly understand. Calcium carbide upon hydrolysis will gives rise to calcium hydroxide, and acetylene is the product. This is the synthetic pathway of acetylene molecule. Okay. At the same time, we are replacing hydrogens with its isotopes deuterium. So that if you add this deuterated water to the calcium carbide, already we have a carbon-carbon bonded with a triple bond over here. And two deuterium atoms are added to the triple bonded carbons at their terminal, so that deuterated acetylene got generated. In either product will be calcium hydroxide of deuterated, right? So that will be provided in the option number 4, C2D2. If you see this is called C2D2. C2D2 is called deuterated acetylene. This will be the product in this reaction. For question number 5, option number 4 will be the correct answer. Let's move on to question number 6. This will be the last question so that we can conclude the session after the completion. Here a session and a reasoning question is provided. The ionic radii of alkaline earth metals are smaller than those of alkali metals in the same compound. This is the question from periodic trends, periodic properties in the groups as well as in the periods of the elements of the given compounds. Ionic radii of alkaline earth metals are smaller than those of alkali metals in the same period. And the reason will be alkali metals have the higher nuclear charge than that of alkaline earth metals. Okay, let's go one by one. Ionic radii. What will be the trends of ionic radii in the same period? If we are moving from left to right, and moreover, first of all, we have to understand what are alkaline earth metals, what are alkaline metals. As main group elements are called alkaline metals. In that is only first main group elements are called alkaline metals. Second main group elements are regarded as alkaline earth metals. Both are base forming metals. They added to water, they generate basic compounds, so that they are called alkali and alkaline earth metals, right? Okay, the trend will be if you are moving from left to right hand side slowly, the size of the radius of the either atom or ion will be gradually decreases. That will be the natural process. Ionic radii of alkaline earth metal. Alkaline earth metal are second main group. Obviously, they will be smaller when compared to alkali metal. This will be the right statement only with regarding to the central element. And reason. Alkali metals have the higher nuclear charge than that of alkaline earth metal. This is the wrong statement. Okay, because alkali metal to alkaline. For example, let's consider simplest one, lithium, beryllium. Lithium atom resided with the 3 protons. Beryllium is accompanied with the 4 protons. Where nuclear power is more? In the alkaline earth metal, beryllium only, because more number of protons at the central core nucleus, more will be the power of the nucleus, so that size will be decreased. Alkali metals are having, lithium is having only 3 protons, right? So that nuclear effect is somewhat smaller. In this manner, alkali metals always having lower nuclear charge, not higher. So that this reason is extremely wrong. So let's see where A is correct, B is wrong. A is correct, B is wrong is given in the option number C. A is true, assertion is true, but reason is false. This will be the right option. Option number C is the correct answer for question number 6. Let's explain in detail in this periodic trends. Positive ion size gradually decreases if you are moving from left to right. Arrow is moving in this manner, size is decreasing. If we are observing from main group top to bottom, so generally the size will be increases. If you consider lithium plus and cesium plus, obviously cesium plus will be larger compared to lithium plus. Okay, so that size of the positive ions gradually decreases from left to right. And effective nuclear charge, what is the relation? Effective nuclear charge gradually increases because more the number of protons are added to same shell, sorry, not same shell, more the protons will be added to the nucleus. That's the reason why nuclear power will be increases, but electrons will be added to the same shell in the outermost orbital. That's the reason why nuclear charge gradually increases from left to right. Positive ion charge size gradually decreases from left to right. So option assertion is correct only. Reason will be absolutely wrong. By this we completed the session. Hope this will be helpful for your preparation towards in any entrance examination or competitive exam as well. Hope you understood well about the concept. Thank you very much for patient listening. And I'm requesting you to like my concept, comment over here if any mistakes are there, and share this with the aspirants whoever preparing for the entrance or competitive exams as well. Subscribe my channel, World of Competitive Chemistry, and thank you very much for your patient listening. Thank you one and all.